Hi, I'm following along with Paul McWhorter's Raspberry Pi Pico W lesson. We're on number 70 and talking about using both cores and exiting cleanly on the Raspberry Pi Pico. Um, Paul showed us a way of doing it in the lesson today, but then he showed us one problem with it, and it was that it didn't exit cleanly if the servo was in motion, and he wanted us to uh, fix that so it would work. So the way I decided to do it is that I thought that he had this running uh, variable here that he was using, and I thought that the running should be not controlled by the main thread like he has shows it in his code, but his running should be uh, controlled or set by um, the second thread or when the servo finishes move. So then that would actually show you that the servo was finished. And then you could check on that in your accept keyboard interrupt, closing out the program, that as long as running was true and the servo was moving, you would just pass and just wait for the running to be false, and then you would get it. So that's the way I set my code up. That just seems like the best way to do it for me. I saw others were just expanding the amount of time they waited on their thread, but then if you had a slow moving servo or something for some reason, you might say, "Well, I got to wait 3 minutes to do something before I close." But no, you best to get a flag from your second core saying, "Yep, I'm done moving. You can go ahead and close the program now." So that's basically what I did. Um, my code is a lot different, not a lot different, but uh, different from Paul's. And Paul teaches a great way of coding, but I like to do my own thing. Plus, I also learned from other uh, students on this uh, channel. There's a lot of good input that I get from other ones. And Charlotte is, I just recently, she was talking about instead of the problem with using global variables, it's frowned upon because it could overlap with local variable names and stuff in programming, and they really don't want to use it. And she came up with this idea or uh, presented this idea that you could use a class variable and not have just have a class with variables in it and no functions or methods or inits or anything else there. So I said that sounds pretty good, and you're not going to get any conflicting variables that way. So it should be a approved way to code, I guess, not frowned upon like global variables are. So that's I decided to use that in my code this week. So let's get to it. So we'll go to our Thorny, and I think I might have something still running here. Let me close out. There we go. So this is what I'm talking about. Instead of having global variables, we're having just this class. I called it flag class, and then you just define a couple variables underneath of it, and then when you want to reference these variables, you just call flag dot running or flag dot s direction or whatever. And I just have some Boolean variables, but you could put, other variables that, speed or something if you had, a number or whatever, or text or whatever you wanted here, you could do it. Any variables, but I just, because we're only using true false flags, I just figured I'd call the class flag this time around. Anyhow, that's basically what we're doing. Here's my imports that we're doing and normal doing. Um, we'll skip my second. This is my second core program. I know Paul likes to call it other core or something. I like to have a descriptive name for what I'm doing, and I just know that I'm going to call it to the other thread. So I set up my servo, called it S1, set up my button, and just called it red button. And basically that's it. Um, the A big difference with what I'm doing instead of what Paul's doing is every time that we get a valid toggle on our button. So this is the button code here, and um, if we get a valid button press, I'm using my less than or equal to less than or greater than sign here to simplify the button logic. That's from Charlotte also, I believe. And then we're seeing if we have a valid button press, and then the button press only if the servo is not running, flag dot running is false. Only if that happens, then do we do uh, uh, set up a new sweep with the servo. I'm printing toggle here just to let me know that I got a valid button press and that it happened when the servo was not moving. So that's it has to pass both of these conditions before it gets to here. And then, like I said, we set our flag dot running to true before we start this, and then we call our thread, but our thread is not in a continuous loop. It just runs, finishes its sweep, and then breaks out, and then finishes and breaks out, so that every time that we get a new valid button press, uh, the thread starts again. I just like it to. There's no reason to keep the second thread running. You got extra variables that you got to keep an eye on and everything else. So we just sweep it and wait for it to get done, and the thread just exits cleanly itself. It doesn't have to have any kind of way to exit or anything. And then we're keeping track, written old and that keeping track of our old state, sleeping for a little bit. So that's what we're doing there. So when we do call this thread, what it does just goes up and um, we have uh, this the running. Like I said, we start when we get ready to call that. We say we're running because we are going to do this uh, function up here, and it's going to run until the servo finishes moving. So um, also have this direction variable up here, and I just have it true or false. It could be clockwise or counterclockwise or whatever, but it's just easier to say true or false. So if the flag S direction is true, then we're going to go from 0 to 180, and we're going to set the position, do our loop, and set our position and sweep around. And if if the other option is false, and so we're going to do an else, and then we're just going to go from sweep from 180 to 0 with this one here. And then what we're doing is we have two things that we have to do before we exit that thread. We got to flip the direction so that next time we're going in the opposite direction on our servo. And then we're also going to make flag dot running equal false, so that that'll be work out fine. And then the thread just drops out, the function drops out, and the second thread is finished or the second core is finished for a while until we get another button press. Doesn't keep looping, waiting for anything. So that all that like I said, that gets us our main thing, our main core. But the homework was to make sure we finish. So that was easy enough to do down here. Now that we got our flag running, where we're setting it in our core, as well as we're setting it in both places, but we're setting it in our core as well to let us know that we're not running that anymore. So when we get the keyboard interrupt, we said waiting for servo to finish. So if it's running, it'll wait, but if it's finished, then it'll just drop through this other thing. Because what we're doing is while it's running equals true, then we're just passing. So this is just a while loop that just runs and runs and runs until uh, uh, the flag dot running gets set to false up here when it finishes. And then we're just printing closing program. So I guess the thing to do is show it running. So I just pressed it and it's running. I should have said had some instructions down there for the person, but I didn't do that. So we'll have to see how that works. How just I'm pressing the red button now, and it's running from one to the other. And you can see they got the toggle up there on the monitor screen. Press it again, it goes the other way. Press it again, and then press it in between. It doesn't do anything. Doesn't print toggle. Doesn't show a toggle because it's not a valid press unless the servo is finished where it's at. But then uh, kind of I'm gonna have to put this down, but um, I got the servo running kind of fast to see this, but let me set the servo down and I'm gonna have my control C ready to go here to be ready to get out of the program. So I'm gonna toggle it again, and you can see it's waiting for servo to finish and then program closing. So it took care of all that while it was sweeping, and it let it close cleanly, and now we have both cores uh, shut down cleanly. Anyhow, that's my homework. I think Paul's probably going to do something similar where he's going to set the flag in the second core to let us know when we're done, when we can shut the program down. Anyhow, that's all I got for today. Thanks for watching. Have a great day.